This video is going to show you how to do some of the more complex decomposition reactions if you have to predict the product. So the first thing you want to notice is that all three of these are decomposition reactions because notice there's no plus sign on the left of the arrow. So you're not mixing anything together, you're not adding anything together, you just have one compound, so the only thing you can do is break it apart. And if the compound only consists of two elements, you can do that on your own. Just break apart the elements, check that if they're diatomic, you might need to put a 2 on them, but you should be able to do that on your own. The problem is if you have a ternary compound, which means you have 3 elements. So notice that all 3 of these examples have 3 elements in the compound, and so there's no way for you to know where to break apart this compound without doing some research. So once you recognize that it's decomposition and that you have 3 elements, what you have to do is go to your reference packet and find the decomposition section in the reactions. This is in your reference packet. And notice that you have several choices here. The first one is just a general showing you that it breaks apart. It's just a general reaction. So you have AB as the compound and it breaks apart into A and B. But the next ones are specific decomposition reactions that will happen with various polyatomic ions. So the first thing to notice is that they all have a capital M, and that just stands for a metal. So it could be any metal at all, but it's going to be some kind of metal. And the charge on that metal is going to change because not all metals have the same number. They're all positive, but there could be +1 or +2 or +3. So your reactions will not look exactly like what's in here because you will need to cross charges. And I'll show you some examples that will help you understand that. So let's take a look at number 1, and I'm going to show you how to break this apart. Number 1, notice that the polyatomic ion here is OH, which is called hydroxides. So you want to find the one that has hydroxides in the reaction, or you could even look for the OH in the compound itself. But somehow you need to be able to take that number 1 and identify that it matches up to letter D under your list of decomposition. Now we can see how it's going to break apart. So we're going to put the metal from our compound with oxygen. Our metal is going to be the thing that's written first because we always write the positive one first. And so our metal here is calcium. So we're going to put calcium with oxygen. And just don't forget that you do need to cross charges on whatever compounds you have the metal with. This one happens to cancel out because calcium is +2 and oxygen is -2. So they happen to cancel out, but they won't always. And then it says plus H2O. There's no way that you would know that that calcium hydroxide breaks into these 2 compounds unless you looked at that sheet. And then the last thing is you would need to go back and balance it, but this one actually is already balanced. You have 1 calcium on each side, you have 2 oxygens on each side, and you have 2 H's. So this one is already balanced. Let's try another one. This time we have the polyatomic ion ClO3. So you can look up the name of that if you want, or you can just find it on the list. So that's called chlorate. But you could even just find it right here, and as soon as you see it in the reaction, you know which reaction to use. So this is going to match up to letter E on your reference packet. And let's see how it breaks apart. This one tells us that the metal is going to go with chlorine. Our metal here is lithium, and we're going to put it with chlorine. Don't forget to cross your charges on that metal. Again, these happen to cancel, but they're not always going to cross out, or they're not always going to simplify. So just make sure that you cross your charges there. And then it says plus O2. I know it's hard to read on my copy, but hopefully your copy is a little bigger and easier to read. It does say O2 at the end. And again, there's no way that you would know to cut the compound like that unless you looked at this sheet. And then again, we still need to go back and balance it. So if we put a 3 here and a 2 here, that will fix oxygen. And then we just need a 2 here for the lithium chloride. So what I want you to do is to pause this video and see if you can do the last one by yourself, just to check if you understand it. And then play the video again and check your answer and see if you got it right. Okay, let's see how you did on number 3. Hopefully you tried that by yourself. So the first thing to recognize is that our polyatomic ion here is CO3, which is carbonate, and that matches up to letter B over here on the decomposition sheet. You can even look in the compound and find the one that has CO3 in it, and you can see it's right there, CO3. So on the other side of the arrow, it tells us that our metal is going to be bonded to oxygen. And our metal in this case is aluminum, so we're going to put that with oxygen. Again, don't forget to cross those charges on whatever you put the metal with. So in this case, we do need to bring some numbers down, crisscross those charges down to that compound. All right, and let's go back to the reaction and see what else we have. And it says carbon dioxide, that's a CO2. And just like I said on the other ones, there's no way that you would know to split it apart like this unless you look at that sheet. So that's why I'm encouraging you to recognize that you have to use that sheet if it's a 3-element compound for decomposition. And now we need to go back and balance it. Aluminum looks good. Carbon we've got 3 of, so let's try putting a 3 here. And I think that fixes oxygen because right here we have 3 times 3 is 9. We have 3 oxygens there, and then 3 times 2 is 6. So that should give us 9 as well. So this one looks like it's balanced.